Welcome back to a highly requested video about pressure in U-tube shapes with fluids. I have compiled 6 similar questions to guide you step by step through analyzing these scenarios. Grab your notebook, calculator, and let's get started. And don't forget to like, share, and subscribe for more physics content. The first question is from October-November 14, paper 13. Question 22. The diagram shows two liquids, labeled P and Q, which do not mix. The liquids are in equilibrium in an open U-tube. What is the ratio density of P over density of Q? First, let's find a line with the same pressure level. Then identify left and right side of the tube. This is left and this is right. First, let's determine the fluids above this line on both the left and right sides of the tube. Both liquids are in equilibrium, which means the pressure on the left side of the tube is equal to the pressure on the right side of the tube. When a pipe is open to the air, the pressure inside the pipe is equal to the atmospheric pressure outside, because air freely flows in and out, balancing the pressures. So atmospheric pressure, or PATM, is when the pipe is open to the air. Now back to our equation. So the pressure on the left, we have PATM because it's open to the air, plus the pressure of the liquid P. On the right, again, the pipe is open to the air, so the atmospheric pressure here plus what we have here is the pressure of liquid P. Now let's cancel both PATM. What is left is the pressure of P is equal to the pressure of Q. So which formula are we using? So here how it goes. The formula for pressure in a liquid is given by this formula, where P is the pressure in the liquid in pascals, rho is the density of the liquid in kilograms per cubic meter, G is the acceleration due to gravity, 9.81 meters per second square, and height, or H, is the depth of the liquid in meters. Now, the pressure of the liquid P is the density of the liquid P times G times 2x. And the pressure of liquid Q is the density of the liquid Q times G times x. Back to the formula here, we have equalized both, and we are going to cancel G and X. What is left? The density of P times 2 is equal to the density of Q. But it's asking for the ratio of P over Q. So the ratio is 1 over 2. So what that means is the liquid Q, the density of liquid Q is 2 times the density of liquid P. So the options A, B, C, D, the correct answer is A. This question is from October-November 2020, paper 11, question 14. One end of a U-shaped tube is attached to a gas tap. with its other end open to the atmosphere. It contains water of density 1000 kilograms per cubic meter, and the heights of both sides of the water column are shown. The atmospheric pressure is 101 kilopascal, and what is the pressure of the gas from the gas tap? Let's first identify the line with the same pressure level, then identify the left and the right side of the tube. Because this liquid is in equilibrium, the pressure on the left is equal to the pressure on the right. So on the left, what we have above this line is the pressure of this gas, and on the right, above this line, we have the atmospheric pressure and the pressure of the water. Now we are using the formula, the pressure of a liquid, which is the density of the liquid times G times the height of the liquid. So what we have here is the pressure of the gas, is the atmospheric pressure, plus the density of the water times G times the height of the water. So let's do substitutions. So the atmospheric pressure was provided is 101,000 pascals. The density of the water was provided 1000 kilograms per cubic meter. G, acceleration of gravity, 9.81, and the height is the difference between both lengths provided, because we are looking for just the height of the water in the tube, in the column. So is 0.314 in meter minus 0.102 also in meters. Now the difference is 0.212 meter, and the result of this operation is 103 times 10 to the 3 pascals. So let's look at the options. So the correct answer is D. This question is from May-June 2012, paper 12, question 23. A pipe is closed at one end and contains gas, trapped by a column of water. The atmospheric pressure is 1 times 10 to the 5 pascal. The density of the water is 1000 kilograms per cubic meter. And what is the pressure of the gas? In this case, it's asking to use G instead of 9.81, use 10 meters per second square. Let's first identify the line with the same pressure level. Then identify the left and right side of the tube. Because this liquid is in equilibrium, the pressure on the left is equal to the pressure on the right. So what we have above this line on the left column is just the pressure of the gas. What about what we have above this line on the right side? We have the atmospheric pressure and we have the pressure of the water. Now the pressure of the water can be calculated by the pressure of the liquid, which is the density times G times the height. Now, what we have in terms of information? The atmospheric pressure is given by 1 times 10 to the 5 pascal. The density of the water is 1000 kilograms per cubic meter, and is asking to use for G 10 meters per second square. Doing the substitutions, the pressure of the gas is 1.5 times 10 to the 5 pascal. Here are the options, and the correct answer is C. This question is from October-November 2015, paper 11, question 19. A U-tube closed at one end contains mercury. Air pressure of 5 times 10 to the 4 Pascal is trapped at the closed end. The other end is open to the atmosphere and is fitted with a piston of mass 5 kilograms and cross-sectional area 5 times 10 to the negative 4 square meter. The density of the mercury is 13,600 kilograms per cubic meter, and the atmospheric pressure is 1.01 times 10 to the 5 Pascal. What is the height h of the mercury column? Let's first find a line with the same pressure level, then identify left and right side of the tube. Because this liquid is in equilibrium, the pressure on the left is equal to the pressure on the right. Now we need to observe what we have above this line. On the left side, we have the atmospheric pressure, and you have the pressure of this piston. And on the right side, above this line, we have the pressure of the mercury and the pressure trapped right here, which is the pressure of this air. Now, we are going to calculate the pressure on the piston because it's different. This is not a liquid, this is solid. So we can use this formula, is the weight of the piston divided by the cross-sectional area. So the weight of the piston is the mass of the piston, which is 5 kilograms times 9.81 divided by the cross-sectional area. So the value of the pressure of this piston is 98,100 pascals. So here is the substitution for the pressure of the piston. So now, since we have the density of the mercury and the value of the atmospheric pressure, so then we can do the substitutions in this equation. So notice that the pressure of this air that is trapped was given right here, 5 times 10 to the 4 Pascal, and the rest is good to go. So we don't have the height, we are looking for the height. Now, rearranging all this, all right, in terms of the height, we have, just follow along with my math. So the height is this value divided by this value, which is 1.1175 meter or 111.7 centimeters. So the options that was given, A, B, C, and D, the closest answer is D. This question is from May, June 2015, paper 13, question 21. A W-shaped tube contains 2 amounts of mercury, each open to the atmosphere. Air at pressure P is trapped in between them. The diagram shows 2 vertical distances, X and Y. Atmospheric pressure is equal to the pressure that would be exerted by a column of mercury of height 760 mm. The pressure P is expressed in this way. Which values of X, Y, and P are possible? Alright, so let's work on this question step by step. First, let's separate both tubes. this and this. And let's consider the air pressure P trapped in between them. At the top is the same for both tubes. I'm going to analyze each U-tube separately. Here is the left section of the W-shaped tube. We are going to follow the same protocol. Number 1, find the line with the same pressure level, then identify the left and the right side of the tube. Considering this fluid is in equilibrium, so the pressure on this left is equal to the pressure on the right. So what we have above this line? On the left side, we have the atmospheric pressure, and we have the pressure of this mercury right here. And on the right side, we have the air pressure trapped between both tubes. So let's call here just P. So let's write it this way. On the left, P ATM plus the pressure, let's call X. The same fluid but different levels, so let me call this one X. And on the right, let's call just P. Now doing some substitutions, so the liquid on the level X is the mercury, so the density of the mercury times G times this height. However, this height is just X, so that's the equation that we have for this side of the W shaped tube. This picture is the right side of the W-shaped tube, and we are going to follow the same step-by-step analysis. First, find a line with the same pressure level, and then identify the left and the right side of the tube. Because this fluid is in equilibrium, the pressure on the left is equal to the pressure on the right. Now let's look above this line on each side. On the left side, we just have the pressure P. On the right side, we have the atmospheric pressure plus this level of mercury at the bottom. Now, let's call this pressure of mercury Py. On the prior slide, I call Px because it was showing a different level. So now let's do substitutions. So the Py is the pressure of the mercury. So the density of the mercury is times G times H. The question is, what is the value of H? So if you look, H here is 5 mm minus Y. So let's go ahead and do this substitution. So it's 50 minus Y. Now, what was given? The atmospheric pressure is equal to the pressure that would be exerted by a column of mercury of height 760 mm. The pressure P is expressed in this way. So this is what's going on. The pressure here is expressed in millimeter mercury, I'm sorry. Now let me combine each side of the W-shaped tube into two U-shaped tubes, each with its own pressure equation. Note that the pressure P is the same, so we can now equalize both equations. So the equation of the left side is this one, and the equation for the right side, the whole tube, is this one. So now we are going to equalize both, and we are going to cancel atmospheric pressure, the density of the mercury, and G. And what is left? X from the left side here of this expression is equal to 50 minus W. Rearrange a little bit better. X plus Y is equal to 50 mm. Now that we have this expression, the sum of the height x plus y is equal to 50 millimeter. Remember, the pressure here is expressed in millimeter mercury. So here is the pressure of mercury with level x. Here is the pressure of the mercury with the level y. And here is the pressure of P that is trapped between both U tubes, the pressure P in mercury, mm of mercury. So both here, this is X and Y, is the level of the mercury, both of them on different tubes. And here is the pressure at point P, which is between both tubes they have in common. Okay, so how we are going to select the correct answer? So since this is X, this is Y, the sum of them should be 50 millimeter. So the next step is to add both values. So 20 plus 20 is 40. 20 plus 30 is 50. This could be one of the answers. 30 plus 20 is also 50. So now we have two options. And 30 plus 30 is 60. So we have two options, B and C, to determine each one is the correct answer. To determine which option is correct, let me look at this YouTube shape where we have the mercury level at X. So here the atmospheric pressure is equal to the pressure that will be exerted by a column of mercury of height 760 mm, which means that the atmospheric pressure is expressed at 760 millimeter mercury. So P is also expressed this way. So let's see how we can use the values of X or 20 or 30 to determine the value of the pressure P on this right side. So here we have this expression. So P is equal ATM plus PX, after rearrange, of course. So the PATM is 760 millimeter mercury, and the PX is the value of X, which is 20, and it say that is express the column mercury of height, so 20 millimeter mercury. So when we add both, we had 780 millimeter mercury, which is the option B. But let's take a look if the PX will be 30. So the same expression, ATM is 760, but now PX is 30. So that will result in the pressure of the air 790 millimeter mercury, which is not an option here. So to finalize this question, so the correct option is B. This question is from May-June 2013, paper 12, question 20. Two bulbs X and Y containing air at different pressures are connected by a tube P which contains two mercury threads. The density of the mercury is 13,600 kilograms per cubic meter. Which pair of values of H1 and H2 is possible? So the first step is to separate both tubes. So let's consider the air pressure at P at the top is the same for both tubes. So let's first find a line with the same pressure level and identify the left and the right side of this tube. Because this fluid is in equilibrium, the pressure on the left is equal to the pressure on the right. So what do we have above this line on the left side? Just the pressure in this bulb X, which is air with a value of 16,000 Pascal. And on the right side, above this line, we have this height with mercury, and we have this pressure P. It's not open to the atmosphere, it's just connected to P. So then we can write this expression. The pressure on X is equal the pressure on P plus the pressure of the mercury. Now again, doing substitutions. The pressure of the mercury is the density of the mercury times G times height 1. So rearrange for P, we have Px minus all this expression. Now let me look on the right side of this original W-shaped tube. So here we have the line, the common line, and this is the left side and this is the right side. Because this fluid is in equilibrium, the pressure on the left is equal to the pressure on the right. So what do we have on the left above this line? We have mercury with height H2, and we have the pressure at P. And on the right side, we have the pressure of the air on this bulb Y. So here is the expression. Again, doing substitution for mercury, we have the density of the mercury times G times the height of the mercury on this side is H2. Rearrange in terms of P, we have this expression. Now I'm going to combine both expressions in one. So here we have Px minus the density of the mercury times G times H1 on this side of this equation. The other side of the equation, I have Py minus the density of the mercury times G times H2. Next, I'm going to rearrange everything because I want to find an expression for H1 and H2. So Px minus Py is the density of the mercury at height 1 minus the density of the mercury at height 2. So what do we have from the question? We have the density of the mercury is 13,600 kilograms per cubic meter. It was provided the pressure of the bulb X with 16,000 pascals, the pressure in the bulb Y, which is 8,000 pascal, and now we are going to do some value substitutions. So Px minus Py on this side is equal to the density of the mercury times G times height 1, H1, minus the density of the mercury times G times H2. The next step is we have in common the density and G, so this is the expression. And now I'm going to divide 8,000 by this value. So the result is 0.06 meter, and in centimeters is 6 centimeters. Now that we have this expression, this is a very easy one. We are just going to subtract H1 with H2. So 4 minus 2 is 2 centimeters. 6 minus 6 is 0. 12 minus 18 is negative 6 centimeters. And 18 minus 12 is 6 centimeters. So the correct answer is D. This question is from October-November 2017, paper 12, question 15. Air is trapped inside a glass bulb, which is immersed in water and attached to a U-tube containing mercury. The densities of water and mercury are ρW and ρm, respectively. The surface of the water is open to the atmosphere, where atmospheric pressure is P. The acceleration of free fall is G. What is the pressure of the air in the glass bulb? And we have 4 different expressions. So let me draw a line at the level where they have the same pressure. Identify the left side of the tube and the right side of the tube. Now we have the atmospheric pressure above, and we have the pressure in the water, that this side of the tube is open to the water, so we have the pressure of the water acting right here in this open side. There is no pressure acting here because it's a sealed bulb. Now we can state that the pressure on the left side is equal to the pressure on the right side. So what do we have above this line on the left side? We have the pressure of the water, and we have the pressure of the atmosphere, atmospheric pressure. And on the right side, we have this section here of mercury, and we have the pressure of the air that is sealed in this bulb. All right, so now what we are going to do is, let's call the atmospheric pressure just P. So pressure of the air is equal to P, which is the atmospheric pressure, plus pressure in the water, minus the pressure of the mercury. Now doing substitutions, P is plus the density of the water is ρW, G, the height of the water is HW, is from the water surface to this level right here, so it's HW. And the pressure of the mercury, which is this small part, is the density of the mercury times G times the height of the mercury, which is given by Hm. So the expression is P plus, I just eliminated the dots between, which is multiplication. Now let's look at the options and see which expression is the correct one. So looks like is option B.